Hello everyone, this is Sriram. Welcome to my second video lecture. This is the Help Cannabis Dealer Problem. Um, so the problem statement is a cannabis retailer company C marks the price of its cannabis up and down every day, which means that today if the price is $10, then tomorrow could be more than 10 or less than 10. And for example, tomorrow if it's more than 10, and assume that the price is 15, and then day after tomorrow it could be more than 15 or less than 15, and so on. So we have an insider trader in this company, I, who leaks the who leaks the selling price of C's cannabis for the next n days to a local cannabis dealer T. So we need to write an algorithm to help the dealer decide when he should buy cannabis from C and when he should sell it so that he earns the maximum profit. Okay, so let's go into this problem and try to solve it. Okay. So okay, so the idea of the dealer is to buy cannabis at a low price from the company and sell it for high to earn maximum profit. So let uh, so initially what one can think is let's say the price is 5, 10, 15 and 20 for the next 4 days. Then one can think that why not I buy why not the dealer buy the cannabis on the first day, on the lowest day, which is $5 on the first day, and sell it when it's maximum, which is 20, and the last day. This way we can just find the minimum and we can just find the maximum and just return their indexes, right? But this is not always the scenario. Let's consider this example. Okay. So this array represents the selling price of cannabis for the next 5 days. Okay. So the price is minimum. So if we talk about the approach that I just said, it would not work in this case because the minimum is on the 5th day, whereas the maximum is on the 1st day, right? So according to that solution, you would suggest the dealer that, hey dealer, buy on 5th day and sell it on 1st day. That's ridiculous. Okay. So excuse me. Secondly, one more approach that we can take is we can find the highest and lowest prices. So we can find minimum price and maximum price from the array, and then work left from the highest price to find the lowest prior price, and work right from the lowest price to find the highest later price. Don't worry if you don't understand this. And then we return the pair with the greater difference. Okay. So if you don't follow this, don't worry, I'll show you a quick example. So forget about the values here, just observe the graph. So by seeing the graph, you would say the lowest price is this, right? Which is on the 5th day, and according to what I said, find the lowest and highest and lowest price, then work right from the lowest price to find the highest later price. Okay. So you would start here, and then you would work this in this direction, and you will notice that the highest price is here, right? and then um, and then you would find the highest price, which is here, and you would work in this direction to find the lowest price, right? And you would take the difference of these two, okay, and return uh, the highest difference, the indexes of the highest difference. So that would be the that would be the maximum, that would be the days when the dealer should buy and sell it out to gain maximum profit. So what I mean by this is, um, if you're wondering why you should do this way, because it can if you trace this using a number of algorithms, I would say you would understand why we are doing this. uh, so firstly, I believe that it's very pretty clear for everyone why you would find the lowest value and go right to find the highest value, right? Because you want to find the difference, because you want to find the maximum difference, right? But assume that on day 8, sorry, I mean 9, we're assume that on day 9 uh, the price was 40, okay. uh, the price was let me do this. Assume that on day 8 the price was 40. So let's say this is 817 and 40, so the price has gone up 23, right? Day 9 minus day 4 equal to 23. Whereas um, from highest to from highest, if you work left and find the lowest, then you would find 60 on day 1, minus day 0 equal to 30, right? So in this scenario, this is valid, this is the valid solution. So that is why you need to consider both. You need to consider the lowest you need to consider the lowest value and work towards the right to find the highest later price, and you need to find the highest price and work towards left to find the lowest price, and compare both these differences and return the indexes with the maximum difference. So that is why we follow this approach. But do you think this solution is correct? Well, this solution almost convinced me that it's right, but unless I saw this one. So here it's assume that big H dash is the assume that the big H dash is the highest price, and small L dash is the lowest price, okay. And assume that big L dash is the lowest price, and small h dash is the highest later price, okay. According to this, let's take this array, okay. So let's use the solution that I just discussed. So we find the lowest price, okay, and find the go right and find the highest later price, which is 25 in this case. So the difference is 15. Okay, and we find the highest price, which is 60 in this case, and we go left to find the lowest prior price, and which is 40 in this case, and the difference would be 20, right? But so 20 is the biggest difference, therefore therefore the dealer must buy when it's 60, which is on day 2, and sorry, which means the dealer should buy on day 1 when the price is 40 and sell it on day 2 when the price is 60. But is this correct? No, because the solution lies here, right? Because the difference between 20 and 50 is 30, so the dealer must buy on day 3 and sell it on day 4. So the above mentioned solution will not work. Okay, so these are the examples that I wanted to cover, because it's very easy to approach to a wrong solution for this problem. So I wanted to cover all these examples before going into the actual solution of the problem. In the description of this video, I will also be sharing this document for your convenience if you want to refer it for later purposes. So I have pretty much explained in detail about these examples, and why these examples fail. So take a look at this document if you have any questions. Okay, so a brute force solution to this problem would be, so to compute all pairs, so for each pairs ij from the given array, we return the pair with the maximum difference, and here there is one condition that I less than j, which means that we have to if I is at 0th position, we should only take all the indexes that occur after 0, and if I is at 5th position, then we should take all the indexes that occur only after 5th position, right? Okay, so this would be the algorithm for the brute force approach, but we are not interested in the brute force approach because if you see, the outer loop runs n times and the inner loop runs n minus I times, because every time let's say we have 20 15 13 25. So first the loop starts here and scans through all this. Next the loop starts here, scans through all this. Next the loop starts here, scans through this. So the outer loop will run n times for each of these values, but the inner loop will run n minus I times, because it should only run on the remaining values of the array, like these values. Okay, so the time complexity of this brute force solution is big O of n square, since n into n minus I will be less than n square. But we can do this, we can solve this problem even efficiently. Okay, so based on the graph in figure 1, let me show you the graph, this one. Okay, based on this graph, I outlined a chart Okay, so this is basically the indexes of the array, all these values, and these are the corresponding values for the indexes. And I also have a third row that tracks the change for ith value and I minus 1th value. Okay, uh, I'll talk about it. I'll talk about why I'm using this change. Okay, and then okay, so let's dive into this efficient algorithm. So in figure 3, like I said, days are the indexes and price are the values, and let's follow a slightly different approach here. Instead of looking at the daily prices, let us consider daily change in price, where the change on day I is the difference between prices after day I minus 1 and after day I, where I 0 less than I less than or equal to 9 in this example. Okay, so basically what I'm saying here is the change is nothing but the difference between it's the difference between these two, right? So 60 minus 30 is 30, and minus 28 is the difference between minus 32, difference between minus 32 and 60, and so on. Okay, one thing you need to observe is, let's say if I want price on day 6. Okay, yes, I can get it from array of 5, right? I can grab this 5th index value from the array, which is 17, right? But I could also do this. I can grab the 0th value 30 and add all of these, right? So 30 including this one. Actually, I could add all of these to get price on 6th day. So 30 plus 30 is 60, minus 28 32, minus 12 is 20, minus 2 is 18, minus 1 is 17. So let's observe this pattern here. So price on day I is equal to price on day 0 plus change on day 1 plus change on day 2 plus so on change on day I. Okay, here is an example that I outlined on day 3 to prove my point. So using this above piece of information, we can reduce this problem to finding a contiguous subarray from the change values, such that the sum of the subarray is maximum. Okay, but why we want to do this? This is because ultimately we want to find out a point in the graph where, you know, the total increase is maximum, right? So this increase could be anywhere. So we want to find that point X, and we want to find that point Y, where the increase in the price of cannabis is maximum, right? And how can we do that? One way would be to add these change values and find the set that yields us the maximum result. So that is why we want to find a contiguous subarray whose sum is maximum. Okay. So for example, in this problem, it is evident that the dealer must buy on day 5. The dealer must buy on day 5 and sell it on day 8. Okay. Because the net increase is 40, and which is the highest, and one way to get the net increase is add these three: 12 plus 9 plus 19, which is 40. Okay, so that is why we want to find a contiguous subarray whose sum is maximum. Okay, so in this problem you'll notice that this is the solution. Okay, so now I want you guys to let you know that this is actually disguised version of maximum sum subarray problem, which is a very interesting problem in computer science, and there is a very detailed explanation of this problem in CLR's book. Please check that solution as well if you are very much interested in this problem. So once you find a subarray like this which yields the maximum, now all you need to do is find out the index of 12 in the original array, find out the index of 19 in the original array, and you want to return s minus 1 comma e. So in this case 12, the index of 12 in the original array is 6, right? And index of 19 in the original array is at 8. Okay, so at this point you want to return 6 minus 1, which is 5, and 8. So 5 and 8 will be our solution. Okay, so let's formalize this problem. So let's consider the array A, and this array A is the information given to us by the insider trader. Okay, and these are the values. I am denoting them as p of 0, p of 1, p of and so on, p of n minus 1, where p of I is equal to price on day I. Okay, so this p of 0 is nothing but price on day 0, p of 1 is nothing but price on day 1, and so on. Okay, so one way to solve this problem is to use recursion, right? Because recursions are easier to code. You could have an iterative algorithm that's like 20 lines, but you could do that using recursion in a couple of lines. There are like hundreds of examples for this. So let's move forward and solve this problem using recursion. And one thing I want to tell you guys out there about recursion is I used to have a huge difficulty writing recursive algorithms. I used to have a hard time understanding recursions, and I was literally scared of recursions, if you ask me. I always used to code my algorithms in iteration, but I actually found a very easy way to write algorithms recursively, and I will be covering a video lecture on how to easily write recursive algorithms in a separate lecture, as that topic is out of scope in this lecture. Okay, so To write a recursive algorithm, we'll be using will be using divide and conquer approach. Briefly, divide and conquer approach means that you want to divide the existing problem into a number of sub problems that are smaller instances of the same problem. Okay, we then solve these smaller sub problems and then combine solutions into the solution for our original problem. Okay, so using this approach, we will divide the array into two halves of as equal size as possible in this way. Okay, so we will divide it here and we call this as mid. Now if you carefully observe, what are we looking for? We are looking for a contiguous subarray with maximum sub. So since the array is contiguous, it could lie entirely here, or it could lie entirely here, or it could lie here, right? So it could lie entirely to the left of mid, or it could lie entirely to the right of mid, or it could lie in between. It could start somewhere to the left of mid and then cross the mid and end at end after mid. Okay, so yep, so these are the three cases. Okay, so problem 1 would be to, now we have three problems. Okay, so problem 1 would be compute the maximum sum sub array of a low to mid, which is the left part of mid. Compute the maximum sum subarray of a mid plus 1 to high, which is the right part of the mid, and compute maximum sum subarray of the at the crossing point. Okay, and once we compute these three, we want to return the indexes of the array with the maximum sum out of these three subarrays. Okay, so if you see these three problems, P1, P2 and P3, P1 and P2 are similar problems. And why are the similar problems, and why P3 is not the exact same problem as P1 and P2? This is because P1 and P2 are sub problems of the problem at hand, right? So basically what I'm trying to say is P1, P2 are the sub problems of finding of finding a maximum sum subarray of an array A0 to n minus 1. So think a bit recursively. Suppose you have an array and of length n. Now if I ask you to find a contiguous subarray of A0 to n minus 2, then this is actually a sub problem to your original problem, right? So same thing here. So assume you have a problem of finding maximum sum subarray of an array A0 to n minus 1. Then P1 is a sub problem of this problem, because you wanna find a maximum sum subarray of some part of it, right? Same goes for P2, whereas P3 is different, because in P3 we have to find a maximum sum subarray such that it crosses a certain point mid here. Okay, So since P1 and P2 are recursive sub-problems of our original problem, let's go and write an algorithm for P3, which is finding a maximum sum subarray such that it crosses a certain point mid. Okay, now here, let me write down the array, and let's trace this algorithm for our original array. To the left, I have the algorithm for maximum sum subarray such that it crosses the mid, and in this example, let's assume that mid is here. Okay. So we want to do iterate from mid down to low. So in this direction, right? Yeah. So in this direction. So initially I starts at mid, and our sum will be equal to -1, since here 0, you're doing 0 plus a of I, which is a of I is -1 here, so sum will be equal to -1. And if sum greater than left sum, since sum is -1 and left sum is -infinity at this point, so if condition is true, it's going to enter and execute these two statements. Okay, so left sum equal to -1 here, and max left equal to what's the index of mid here, 0 1 2 3 4 equal to 4, right? After that, we are going to add -2 to sum, which is -3, and -3 is not greater than -1 here, so it won't enter this if block. So same happens with -1 and -28, but when it reaches 30, so sum will be -12, -28, and -30. Sorry, plus 30. So what's the total sum here? Minus 14, 42, 30. This is minus 12, -1. So yeah, so even after the loop reaches at 30, the total sum value, this is equal to -11, which is, and is -11 greater than left sum? No, because left sum is -1. So this loop for this example will run only one time for -1. I mean, these if block, the statements under the if block will run just once, and that is for -1. And coming to the next for loop, so sum equal to 0 initially, and we are iterating from mid +1, which is here and in this direction. Okay, so sum equal to 0 plus a of j, which is 12, so sum equal to 12, and is sum greater than right sum, and right sum is -infinity at this point, and yes, the condition is satisfied, and this is executed and this is executed. So right sum equals sum, which is 12, and max right equals 0 1 2 3 4 5. Okay, after that, for the next iteration, j is here, and sum equal to 12 plus 9, which is 21. Is 21 greater than right sum? Yes, it is. So right sum will be 21, and max right is going to be 6. Okay, and then next, j is here. It's going to add 19 to sum, which is 40, and is 40 greater than right sum, which is 21? Yes, so right sum is going to be 40, and max right index is going to be 7. Next, j is here, so you do sum minus 7, which is 33. Is 33 greater than right sum? No, because right sum is 40, so none of these execute. Okay, so this way now we are returning max left, max right, left sum plus right sum. Okay, so what's left sum plus right sum? So we will return max left 4 comma 7 comma 40 minus 1, 39. So this is the maximum sum subarray such that we cross a certain point mid for this example. Okay, now if we go back to solving this problem, so we have broken down our problems into 3 problems, which are this: compute the now we have solved 1 second. So we have solved this problem. Okay, and why we chose to solve this problem? Because this problem was not a sub problem of original problem at hand. Okay, so we have solved this, and if you look at the final algorithm, so if if high is less equal to low, that would be the base case, which means that we have only one element, and we just written high, low, and a of low. So this part is done, right? And what would be the we have how much? Let's see, 4, 7, and 39. 4, 7. This is, oh my god, this is so problematic. 4, 7, 39. And for this, okay, so this is a recursive call to right? Now what this does is it will try to recursively compute the maximum sum subarray of this array, and so remember that I will make separate lecture series for recursion problems, but computing recursively, it will return this solution, which is it's going to return 5 0 1 2 3 4 5 6 7, and what's the sum? 40, right? And so as this one, it's a recursive call to itself. So it's going to compute recursively the solution for this subarray, and what will this return? It's going to return just 30, right? Because you cannot return this, you cannot return any of these actually, right? So it would only return this, just one element, and it would return the indexes 0, 0 and 30, right? So now you have 0, 0, 30, and you have 5, 7, 40, right? 5, 7, 40. So this is the solution of this, and this is the solution of this, and this is the solution of this. Okay, so in the next three, we are just make if and else statements. We are just making comparisons and returning the right solution out of the three. So in this case, we will return this. So it suggests that the dealer must buy it. The dealer must buy the cannabis on, where is this? So suggests that the dealer must buy cannabis on 5th day and sell it on okay, wait, okay, so actually if you see in this problem, we forgot to add this value here. So this will be here, which is an empty value, and this will be this is going to return 1, 1, and this is going to return 6, 8. Okay, so with that in place, we will return 5 and 8 as solution, because remember we said we are going to return s minus 1 comma e. So we will return 6 minus 1 comma e as the solution. So the dealer must buy it on 5th day and sell it on 8th day for the maximum profit. So that is it for this lecture. If you have any questions, I will post I will actually be attaching the document in the description, but if you still have questions, please post your questions in the comments. If you find any mistakes with my solution, please do mention in the comments, and I'll see you next time. Bye bye.